Hans, what results from phase one can you share with the public, and what are the next steps for the additional phases of the study?
Yes, this project is in a way is unique in the sense that because of the timeline by which everything had to happen and the current rulemaking process, and that really put everybody on the spot on sort of making the best effort in getting the science right in a very short time. What we did here is we first took the data that we had available from the experiment that I described earlier and put this in the data from that in a mathematical equation as part of a model of fatigue that we had already produced, and expanded that model to make predictions for workload so that we can predict and actually get estimates of what the effects might be of multiple takeoffs and landings in the context of time of day and time awake and other factors that we already knew would be involved in fatigue. As part of the rulemaking process, as part of the notice for proposed rulemaking that's out there right now, we actually looked at the FAA recommendations and used the model to see to what extent the FAA's recommendations, especially as compared to the ARC, as proposed by the ARC before that, made sense, and to what extent they might be overly relaxed or overly restrictive. And I'll spare you the exact details right now, but we found that there are a couple of points where the FAA and the ARC disagreed, and it seemed that the ARC was actually better informed than what the FAA had proposed. And I realized that there are multiple elements that go into how such a decision is made, but there is room for discussion there, and I think room for using the science to see what the best decision would be, and how things can be even improved beyond what's already on the table. That more or less is what came out of phase one, but there is an important step that needs to be done because of the way the timeline was organized, in that we still need to prove that even though the model that we have now is based on laboratory science, we have to see if that actually works the same way as we see in a lab if you put it in the aviation environment. And so in phase two, what we're going to do is we're going to do a simulator study using the high-fidelity real-thing simulators that the airlines have at their disposal, and fly duty schedules that are otherwise standardized, but compare long-range flights to multiple takeoff and landings, multi-segment flights, and see if we can, first of all, if we can identify the effects of the extra workload from those multiple takeoff and landings, and then quantify and see how big those effects actually are, and then compare that to the model predictions we had, and then subsequently see if there's any adjustments needed to the model, and so improve the model that way, and at the same time validate it so that we can say, yes, what we know about the science of sleep and fatigue as it relates to workload, what we think we know is actually true, holds up in the aviation environment. And if we can prove that, that means then that we have a model that now extends all of the knowledge that we have on sleep and fatigue to any combination of time of day, time awake, and how many segments do you fly, which is really what the FAA is all thinking about, but they don't have the science in hand just yet. And so we will at that point have that available, and that means we can then subsequently use that knowledge to make schedules that take all these factors into account, that keep the operation as fatigue friendly as possible while still being able to fly and get people to places. And so get the best of both worlds combined. And so phase three is then really an advisory phase on how we can use this model and what we've learned over the project so that regional airlines can implement this into their operations and use that to optimize the operations, so to make them as fatigue friendly as possible while still doing what they're there for.